Hi, so here is Xingyang Cui. So I'm lead by the Doctor Who and in the bioscience group. And my research topic is related to the transfer learning for the Tarsus segmentation by using the foot and ankle pretrained model under the limited data. So to explain it, it's just like currently we already have a model for the foot and ankle segmentations, just like you can see in the images under the objectives. So they have our baseline models. So you can correctly segment for different part of the foot and ankle, like the tibia, the tarsus, and each of the toes. But we came across another idea is like currently we use a very big data set to training for the model. But in the future, in some domains, we may not have that much data, like in the pediatric domain. So we're trying to say if we only use limited data, like we only have 11 CT scans as the ground truth, can we separate another part? Like for our baseline model, all the terses are in the same parts, like in the same label with like the blue colors. And we're trying to say if we want to separate these terses into 7 parts, like the calcaneus, the navicular, but only with limited data set. Is that possible to do that with the transfer learning? Since if we want to train a whole new model to separate it with a limited data set is impossible. So the method we use is also based on the NUNet we use for the segmentations. So as you can see in the left bottom, there has the image that is the 3D fuller resolution UNet. That is the architecture of the NUNet model we currently use. And it mainly have two parts like the encoder and the decoder. Encoder part it just extracts the images and the parameters from the images, and the decoder part will do the classification part and like the output to do the segmentation results to us. So the things we first to do is like we have a baseline model development. So currently we're already training a new model for the foot and ankle, and after that we use the transfer learning with the unfreezing and freezing. That means we want to freeze the encoder parts. Like since the model is in the same domain, is also in segmentation but with the foot and ankle. But the only things change is that we want to separate more. Like previously we separate tarsus as one part, and currently we want to separate it into 7 parts. But for the others, like the tibia, the toes, we also separate them in the same way. So the way we extract the detailed data from the images is almost the same. That's why we're trying to freeze the encoder part, like change this part didn't change, and we only do the fine tuning to the decoder part. So like in this way, we have used this idea to traverse for different strategies, like fully unfreeze, like training for the new model, and also we full freeze with the encoder part, partially unfreeze for the encoder part, and also the final is that we do the progressive unfreezing, and that is the best way we currently figure out. So for the results, you can see if we only based on the limited data like 11 CT scans to train for the original training, like retrain for a new model, you can see the result is really bad. So it can even not identify anything like the bones successfully, like in the middle bottle. And in the upper left right corner, you can see the results based on the frozen older encoder layers. So this result is more better than before, but the leakage is still that some of the bones are like leak off some parts, and they did not separate really well, also for the tarsus. And based on the progressive and freeze, that is the best method we find it right now. Like it can first for different approach, it will freeze for the different part of the encoder and progressively unfroze this part. That's why his result is currently the best. So these results show that the strong performance on the separate Tarsus segmentations based on the transfer learning. And for the future work, we will extend this approach to the pediatric dataset and also for some other limited dataset for the broader anatomy coverage. Yeah, that is the basic of my research about. Thanks for listening.